Here's a delightful cartoon that illustrates the concept of a half-life. What we see here represented are 3 half-lives. From 0 to 24 minutes is one half-life, 24 to 48 minutes is a second half-life, and 48 to 72 is a third half-life. So there's 3 half-lives that have elapsed over the course of these 72 minutes. All right, now if we were to count up these balls that are representing our nuclear reaction here, we have 24 balls at the start of this reaction. After one half-life has elapsed, we've lost half that number. We've gone from 24 down to 12. After the second half-life, we've gone from 12 down to 6. Our third half-life, we go from 6 down to 3. So each sequential half-life, we've lost 1/2 of the amount that was there prior to that half-life. Let's look at this mathematically. Mathematically, we can represent this as A of t is equal to A0 times 1/2 raised to the n power. Okay, A of t is the amount that we have at a given moment in time. A0 represents how much we have at the start. So if we look at our cartoon, we see A0 is going to be equal to 24. After one half-life, what we have left is 12, or the initial amount multiplied by 1/2. 24 times 1/2 is equal to 12. So we've gone from 24 down to 12 after one half-life has elapsed. After an initial half-life goes by, we go from 12 to 6. So we have our initial amount multiplied by 1/2 twice, or 2 half-lives, n is equal to 2. So we have 24 times 1/2 times 1/2. That gives us the amount that's left after 2 half-lives, which is 6. After our third half-life, we've gone from 6 down to 3. So we calculate the amount that's left after 3 half-lives. Okay, n is equal to 3. 3 half-lives as our initial amount multiplied by 1/2 raised to the third power, or 1/2 times 1/2 times 1/2. And that equals 3. The amount left after some amount of time has gone by is equal to our initial amount multiplied by 1/2 raised to the n power, where n is going to be equal to the number of half-lives that have elapsed. So let's apply this equation to this problem. In this problem, we've been given our initial amount, A0, the amount at time is equal to 0, as 25 grams. We're asked to determine what A of t is, how much is left after some amount of time has gone by. To answer this question, we're going to apply our equation here, but we need to know how many half-lives have elapsed. We divide our amount of time by the length of each half-life. So we have 96 days divided by 8 days per half-life, so we have 12 half-lives. We input our values from the problem into our equation. The initial amount is 25 grams, and the value of n is 12, and we get our answer. Okay, let's talk about the calculator skills. Putting in 25 is our initial amount, and we're going to multiply it by this entire thing. So we're going to first put in 1/2. I save time. Instead of doing the whole parentheses bit, I say 1/2 is equal to 0.5. So this gets in 1/2, and we're going to raise it to this power. And we need to make sure we raise this to the power 12. So we're going to put 12 within parentheses. Open parentheses, 12, close parentheses.